Okay, well, let's start back up at number 7. Let's see, on this one, we've got g of x equals x minus 3 squared. So let's first decide what shape we've got, which parent shape we've got. It's an x squared, so that's going to look like this. That's the quadratic function, x squared. It's a parabola again. We will get intimately familiar with the parabola. So I'm going to write the parabola right there, just to remind myself that that's what this looks like. If you want to draw it in here, 0, 0, -1, +1, 1, 1. Go over 1, up 1, over 1, up 1. It's a symmetrical little rat face. Now let's do his little ears. Over 2, up 4, over 2, up 4, and draw him in. Okay, so that's the original graph of the parabola. Now we want to shift him or translate him. Both of those words are good, translations or shifts. Let's see what we're asked to do. In the HServe list of things, we have only one shift we have to make, and that's a shift on the x-axis. That's a shift on the horizontal. A horizontal translation. Remember, the horizontal translation, the one within the x, is always a liar. So we want to go +3 on the x-axis, which is 3 to the right. That's all we're going to do. We're just going to pick up this whole entire parabola and scoot over 3 to the right. So the vertex point, oh, let me show you on the vertex point too. This vertex point is 0, 0. Let's look at what the new vertex point is. 3 to the right, so that's a 3. And then grab what number sits there. Well, there is no number. Remember back in this previous one, we just grabbed a -3 off of there as our new vertex point. There is no number back here, so 0 is our shift on that. So this is our new vertex point. Go out 3, 1, 2, 3, but don't go up. So there it is, 3 to the right. It dovetails with either one, using the vertex point or using the translation. And then I'm going to draw my little rat face here, over 1, over 1, over 1, up 1, over 1, up 1, and then over 2, up 4, over 2, up 4. So we just scooted over 3, that's all. We had one minor movement, one minor translation, one minor shift. Okay, let's look at what's going on number 8. Again, you've got to identify what you've got here. X squared, that's a parabola. So I'm just going to go ahead and draw in the original, the f of x, over 2, up 4. From the origin, over 2, up 4. There he is with his little beady eyes and his nose and his ears. Draw it in gently. And now let's do a shift on him. We have no numbers in front of x squared, so we don't have to do the t-table. We don't have either of those. We're not going to worry about those. And in fact, we don't even have a horizontal shift. There is nothing going on between the x and the 2. Look at the previous couple. X minus 3. Minus 3 was between the x and the squared. That's a horizontal shift. Plus 2 was between the x and the 2. That's a horizontal shift. The number that appears between the x and its functionality, what tells you what it's doing, that's where you're going to do the liar business, on the x-axis. But this one doesn't have any information for us, so we are not going to be shifting horizontally. So our new vertex point is not going to change. It's still going to be a 0. But this guy tells us a shift. This guy tells us on the y-axis, outside of the x function. This tells us to go down 2. Remember, he doesn't lie. So he's saying -2 on the y-axis. So we've got a horizontal shift. No, we don't. We've got 0. No shift there. We have a vertical shift of down 2. Okay. That means the new vertex point is at no change, -2. 0, -2. 0 says don't go sideways. -2 says go down 2. And now I'm just going to move this whole guy down. Over 1, up 1, over 1, up 1. And you could just sloppy graph this in, no problem. There, the orange is the g of x. That's the new parabola on this translation, on that shift. Let's keep doing this. Okay, we got a lot going on in this one. In fact, we got everything going on in this one. H serve, we've got a horizontal shift right there. Stretch, we've got a 2. Reflection, we've got a minus. And vertical shift, we've got a 3. And you can't do them in any old which-a-way order. We can combine those two. That's good news, and we will do that. So let's do what we did a couple of problems before. Let's start out with our original points. Okay, well, the first thing we got to do is figure out what we've got here, what kind of shape this is. This is an x squared, so this is also a parabola. This is our third parabola or so. Yeah, the fourth parabola that we've done. Fourth parabola, because you can see the x squared in the central location there. So it will be a parabola. So it's got 0, 0. I'm going to put it in the middle there. 0, 0 as his little nose. -1, +1. His other eyeball is 1, 1. That's a 1 right there. Then I'm going to go -2, +4. Meant that up there. -2, +4. And then his other ear is +2, +4. Okay, that's the original parabola. That's the f of x. Okay, we're going to do a lot to this guy. So the first thing we're going to do is a horizontal shift. That's a +1. I'm hoping by now you're remembering that that's not true. That's going to be a -1. It's going to be to the left 1, or a -1 on the x-axis. This is the only time we're going to mess with the x-axis. So on this -1 of these 5 points, I'm going to go on the x-axis, -3, 4, -2, 1, -1, 0, 0, 1, and then subtracting 1 again, 1, 4. So there is just the horizontal shift, and that happens on the x-axis, and it's always a liar. Now let's do the next step, which we can do 2 at a time. We can do the shift and the reflection. Sorry, the stretch. The stretch. 2 is our stretch. That means we're going to pull these ponytails up. We're going to stretch them by 2. They're stretched by 1 right now. We're going to stretch them a little bit taller, and we're going to flip it across the x-axis down here. That just means, and we can do these at the same time, we're going to multiply each y times -2. So keep the x's. Don't change them. The only time we change the x's is on the horizontal. Let's subtract 2 on the y's now. Or sorry, multiply times 2. Multiply times 2, because it says times -2. So this was a 4. Multiply it times -2, and we get -8. That's a 1. Multiply it times -2. 0 times -2. 1 times -2. And 4 times -2. And then our final step is a vertical shift. That's this guy at the end. That's a +3. And that, again, always, it's going to be out here on the y-axis. We're going to add 3. That's the truth teller right there. This is the only liar on the x. So let's keep those same points on the x. And let's add 3 to each of these y's. So -5. So I need that again, Brandon. So for the SR, you always multiply it by itself. You multiply whatever number sits out there. You're going to multiply the y's, the original, not the original y's, but the y's as we've taken them so far, the y column. You're going to multiply it times -2 to get the new y column. So 4 times -2, 1 times -2. You won't mess with the x's. The only time you mess with the x's is on the horizontal, on the H shift. Does that answer your question? If it doesn't, that's okay. So if it was -3, no, you multiply, I'm not sure where you're, if it was -3, yes, yes, that was me misunderstanding. Yes, if this had a -5 out in front, I would have put multiply by -5 right there, and we would have said 4 times -5 is -20. 1 times -5 is -5. So yes, it's that number right there that we're going to multiply the y column times when we do both the stretch, that's the 2, and the reflection, that's the negative. We can do them at the same time. That mathematically will work. It is pretty simple, but it's a lot of pretty simple. I mean, we started here. We're doing all this mess here. Okay, so it sounds like you're good so far. And then the last step, the vertical shift or the vertical translation, those are interchangeable terms, translation and shift. We're going to add 3, and that's always going to be to the y, and it tells the truth. So take that -8, the current y, and add 3 to it. Take this -2 and add 3 to it. Take this 0, add 3, and add 3. Okay, let's go graph that. -3, 1, 2, 3, -5, 2, 3, 4, 5, right there. -2, -2, 1, right there. -1, 3, 1, 2, 3. 0, 1, and 1, -5. Okay, so easy to spot is that we flip this upside down. That's what the negative did to it. It flipped it upside down. That's what a negative in front of the function does, is it reflects it across the x-axis. I'm hoping you can also tell that this black one, the F1, was a fat parabola. This is a skinny parabola. That's as a result of multiplying the y's times 2. We stretched them out. Okay, let's move to a new shape. Will my math lab always give you the original graph? No. Sometimes do, sometimes don't. We don't have that many. You'll come to realize we really don't have that many. And refer back to this sheet. You can't use it on the test, but you will know them by that time. You'll be comfortable enough with them, I promise. Okay, so that's parabola, and you identify it by the x squared. That's what you're looking for, is x squared. That's the parabola one. Okay, let's move forward to a new parent graph. This is the square root. This is the square root of our x. So the parent graph there is the square root of x. Let me grab that one for you. The square root of x looks like this. It's the arm of the guy lying down in the grass or lying down on bed. Here's his head that we don't have. His vertex point is 0, 0, and that's his arm as he's lying on his side. Okay, let me tell you where those points come from. Let's build ourselves a t-table. Starts right here at 0, 0. The next point is over 1, up 1, 1, 1. The next point, I'm going to put in, I'm looking for perfect squares. 0, square root of 0 is a 0. Square root of 1 is a 1. I'm going to go to 4 next. Square root of 4 is a 2. So 1, 2, 3, 4, 1, 2 is the next point on him. And then the next perfect square is a 9, and the square root of that is 3. So way out here. So this guy, that's how we develop the square root function. He's just a leaning line. You're not going to have to be perfect on that. I just want you to know where it comes from. Okay, so in our little group of H-serve, we don't have a number in front of the radical. We don't have a number in front of the guy lying on his side. So we're not going to have to worry about stretching or reflecting. So we're just going to worry about the vertex point. We don't need to build t-tables. So let's look at what the new vertex point is here. We're going to look at what's happening within the x function. So just like on the parabola, when you find a number that's huddled here with the x, that's going to be a liar. So let's make it a -2. That's going to be our shift on the x-axis. We're going to come -2 with all of our shoulder. And then look at this one outside of that function. There's the square root. That's where it stops. This is outside of it. That's our vertical shift, and it's a -3, and it doesn't tell lies. So we'll be going down from there. So for all of these points, every one of them, not just these 3 you see here, but every single one of them all along that function, we are going to go to the left 2 and then down 3. That's what these instructions tell us to do. Horizontal shift is to the left 2. Vertical shift is down 3. So let's just grab this guy and relocate him at -2, -3, which is the same thing as moving him to the left 2 and down 3. It just depends on which way you kind of prefer. And then because you're going to be matching, you can just draw it in on here. I'm not that picky, but I want to be a little pickier. The next one is over 1, up 1, so right there. The next one is over 4, up 2, so 1, 2, from the vertex, 1, 2, 3, 4, up 2, and that's good enough. I'm going to draw that in, and you can see that that is the same shape, just shifted over to the left 2 and down 3. We didn't need to use this map of t-tables because it didn't involve stretching or reflecting. Okay, let's see what the next one is. Let's first identify what shape we're talking about. We're talking about the square root of x. So that's going to be, a shoulder. We're going to build a shoulder. Let me go ahead and draw it in. 0, 0, 1, 1, go out 4, 2, 3, 4. That's the next perfect square. Up 2, and then out 9, up 3. So something like that. Close enough for our work. Okay, in HServe, we're going to have no shift on the horizontal. There isn't a number burrowed here underneath the radical. So we're not going to have an H shift. We do not have a stretch. We don't have a number here. There's not a 2 or a 5 or a 3 coefficient sitting in front of the function. So we are not going to have a stretch. We do have a reflection. And then finally, we have a +1. Now, some of you are gifted with this visual ability, with this ability to foresee what this is going to look like. I don't have that so much. I mean, I can play the game after years of it. But if you have the ability, first we've got to reflect it. So instead of this upper arm, it's going to be down here. And then you're going to have to scoot it up 1. Boom, right up there. And you're going to have to draw it in like that. If you can do that and match it fine, you'll be okay. No problems if you can match it to the graphs. I'm going to go through the points because especially that reflecting is not my best thing. So let me get the original points. That was 0, 0. The next perfect square is a 1, and the square root of 1 is 1. The next perfect square after 0 and 1 is 4, and his square root is 2. And the next perfect square is 9, and his square root is 3. Okay, first thing I need to do is reflect that, and that means changing the y's. So the next time around, I'm going to times -1. I'm going to, now that looks like an x, So I'm going to multiply by -1. It's a -1 sitting there. So I'm going to keep the x's, and I'm multiplying times a -1 because that's what sits out here, and that's what happens in reflection. Let me remind you. Reflections across the x-axis, a minus in front means reflect across the x-axis, or if you prefer, change the value of the y to its opposite. So that's what we're going to do, is opposite of 0, opposite of 1, opposite of 2, opposite of 3. Now, as a final step, I'm going to add 1 plus 1 to each of the y's. That will allow me to shift it up. So keep the x coordinates, add 1 there. 1, 0, -1, -2. And let's graph those. 0, 1, 1, 0, 4, -1, and 9, -2, way out there. So we're doing something like that. Now, some of you were able to visualize that. Well, some of you. How many are we anyway? Just 2. So, but other people will be listening to this. Some of them will be able to visualize this as reflecting the original the original black arm across the x-axis, so that brings him down here, and then a +1 bumps him up 1. But anytime I've got anything up here, I'm going to go ahead and do the t-tables. You do you. Okay, learning a new parent graph here. This is the absolute value of x. That's the original graph. Let me remind you of what that looks like. Absolute value is a v. It's like a parabola, but it's hard. It's got v's going on. I think I'm always going to do the tables just to be safe. Totally fine, Brandon. Totally fine. You do whatever works for you. I have to. I cannot deal with a number in front here well, because after that you do this movement, and that bugs me. I hope that when it doesn't involve shrinking and stretching, we're not shrinking. When it involves stretching and reflecting, that you can handle the vertical part. Do that and not build the t-tables. But you do you. Okay, so let me put in this. This is going to be 0, 0, and then we've got a 1, 1, a 2, 2, a 3, 3. And then on the back side, if you put a -1 in there, you're going to get a +1, because that's what absolute value does, is just change a negative to a positive. -2, +2. -3, +3. So there's our v. Let's see what we're going to do to him. In HServe, we don't have a number or a sign in front of the x function, so we don't have to worry about stretching and reflecting. So all we do have to worry about is the horizontal change, the horizontal shift, and the vertical translation, the vertical shift, the vertical change. So this is an easy, just go to the vertex point. This is a liar, +2. This stays the same. Let's take this vertex point here, the belly button of this absolute value function, and let's move him to 2, 1, and then draw him in. So 2, 1 is over 2, up 1. There it is. That's the new vertex point. Let's draw in our absolute value, and there he goes. That's all you have to do when it does not involve a negative or a number in front of the x function. This was a shift. Sometimes you're asked to come up with a new vertex point. Sometimes you're asked for the shifts. So let's look for the shifts. This was a shift on the x-axis. It's a horizontal shift of +2 or to the right 2. All those things. This shift happens on the y-axis. That's the vertical axis. That's the vertical change. It's the vertical change. And it is +1, and that's going to take it up. So it's going to go up from there. These things you don't need to memorize. You know these things. You know that this is a shift on the x-axis because there's the x looking at you. And I'm hoping that you know, take that piece out. You know this